I want to start with the room I was lucky to be in before I had any real right to be there. In 1990, just a couple of years into my graduate work at Berkeley, Sung-Hou Kim took me along to a Gordon Research Conference. I'd already been fortunate enough to publish a couple of papers, and he gave me the chance to stand in front of a serious room of crystallographers and talk about neural networks. For those who have been to Gordon conferences, you know the atmosphere. No formal proceedings, no published notes, just scientists pushing each other, testing ideas, forming collaborations, and sometimes asking very hard questions in very public ways. They are incredibly stimulating, and for a young graduate student, they are also terrifying. I remember my presentation vividly. I was on the stage, peacocking a bit, talking about these things called neural networks. I was speaking to hardcore crystallographers about predicting disulfide bonding state from flanking amino acids and other sequence-derived features. I was so naive and so wet behind the ears that I did not fully realize everyone in that room could have crushed me intellectually. Then, someone in the middle of the audience spoke up, loudly. He said, "That's no big deal. We knew that decades ago." The room went deathly silent. You could hear a pin drop. And I had no idea what to say. I had not even taken my orals yet. The best I could manage was something like, "Well, we have more information now." Fortunately, Sung-Ho stepped in and rescued the moment. He did not have to. He could have let the room do what expert rooms sometimes do to beginners, but he did not. He helped me stand back up. That moment stayed with me for a long time. At first, I remembered it as embarrassment. Later, I understood it as a lesson about expertise. Expertise can be used to close a door, or it can be used to hold the door open for the next person. The strange turn is that years later, when modern AI really exploded into public attention, I started hearing that older voice in myself. People were suddenly discovering neural networks, embeddings, language models, and machine learning. And some part of me wanted to say, "That's no big deal. We have been doing this for decades." That statement is not entirely wrong. I had been working with AI ideas since the 1980s, but it was also the least useful sentence in the room. It was the same sentence that had once shut down a young version of me. It was the voice of someone protecting territory instead of inviting people in, so I had to reframe it. The better sentence is not, "We did this already." The better sentence is, "Come join the party," because this moment is different. It is not different because every idea is new. It is different because the interface is new. The audience is new. The number of people who can now participate is new. We have more information now, yes, but more importantly, we have more people at the door. That is why Sung-Ho's lab matters so much in this story. Looking back, his lab was already an AI lesson even before we would have described it that way. It was not one lane. It was crystallography, biology, chemistry, computation, method building, and a group of people willing to collide ideas with each other. That kind of environment teaches you something AI still depends on. Representation matters, context matters, and the best answers often come from putting orthogonal disciplines in the same room. AI is not just a clever algorithm floating in the air. It is a way of mapping inputs to outputs. And the hard part is almost always deciding what the inputs mean, what the outputs should be, and what kind of structure lets the system learn something useful. Sung-Ho's lab was a public institution ideal in that sense. Berkeley gave us world-class science, but also a density of disciplines and people. The lab created a place where computation could sit next to molecular structure, where biology could talk to chemistry, and where a graduate student could learn that science is not a single path. It is a network of paths. I attribute much of my career trajectory to that environment. Even something as small as a promotional flyer on Sung-Ho's desk mattered. It was for a company called Molecular Design Limited. He did not need to tell me to call them. I suspect he may have left it there intentionally. I saw it, I reached out, and that helped create the next turn in my career. From Berkeley to MDL, then to Affymax, then to Eidogen-Sertanty, the thread was always the same. Complicated data, biological or chemical meaning, and the challenge of representing the problem well enough that a machine could learn from it. So the long AI arc on this slide is not meant as a resume, it is context. At the Colorado School of Mines in the 1980s, I was already working with neural networks. At Berkeley, I used them for protein structure-related problems. At MDL, I worked with molecular fingerprints and biological activity. At Affymax, we were dealing with large experimental systems and high-throughput data. At Eidogen, the work continued into drug discovery, molecular similarity, knowledge systems, and applied AI for life science. The theme across all of that work was not simply AI, the theme was representation. How do you describe a molecule? How do you describe a protein? How do you describe an image, a document, a patient, a meal, a scientific claim, or a memory? Once you decide how to represent the input, you can start mapping it to an output. Activity, similarity, risk, structure, relevance, meaning, recommendation. That is the old AI arc. We built tools with AI. What is different now is that AI helps build the tools, and it can do that in English. That brings us to natural language programming. For most of my career, if you wanted software, someone had to sit down and write code. You needed a software engineer, or you needed to become one. You had to know the syntax, the libraries, the environment, the database, the deployment pipeline, and all the annoying details that stand between an idea and a working tool. Today, something fundamental has changed. You can describe what you want in ordinary language, and the system can help build it. Not magic, not automatic judgment, not a replacement for knowing what good looks like, but a new front door into software. Every project on this slide was built through natural language direction. I did not sit there hand coding these line by line. Not because I could not code. I have coded for decades, but because I did not have the time or interest to drop into implementation every time I had an idea. What I had was the ability to describe the need. Toast Our Friend came from a very human need. Honoring people while they are here, preserving stories, creating tributes, and giving communities a place to celebrate lives that touch theirs. AI Dad came from another human need, legacy, memory, voice, family context, and the desire to preserve wisdom across generations. AI Steve is personal AI infrastructure grounded in my own content, email, documents, images, calendars, code directives, memories, and the systems around them. It is not just a chatbot. It is an attempt to build a governed loop around real context. Image Explorer came from the simple but powerful idea that decades of photos should be searchable by visual meaning. Find the face, find the place, find the moment. Do not make the human remember which folder contains the memory. The CT viewer is one of my favorite examples because it is so specific. I came home from an endodontist with cone beam computed tomography data. The viewer they provided only ran on a PC, and I had a Mac at home, so I asked an AI agent to help build a browser-based CT rendering tool so I could inspect the imagery. That tool let me collaborate more intelligently with a highly specialized field clearly outside my own lane. Lee identified a failed root canal, and I went in for a second elective root canal. It turned out that the tooth had a greater infection associated with it. So here was a natural language built tool created for a personal problem that helped me participate more meaningfully in a specialized medical discussion. Food is medicine is another example, but from the other side of my life. My day job is working with pharmaceutical companies to help identify and discover new drugs. Many drugs have roots in nature through natural product screening. Food is medicine reverses that lens. Instead of asking which natural compounds become drugs, it asks which foods, ingredients, and dietary patterns may align with known biology and therapeutic mechanisms. Then Food Health and Food Health TXD bring that idea down to the handheld device. Nutrition tracking, meal analysis, blood glucose awareness, and a diabetes-focused companion shipped to the App Store and Google Play. The point is not that everyone needs my exact apps. The point is that the barrier between a practical health idea and a usable tool has collapsed. And the music grid below is a hobby example, but a very real one. I bring musicians together in my studio for mix and match sessions. We record audio and video. I am often playing drums, running sound, watching levels, and trying to keep the session moving. My hands and feet are already occupied. Afterward, I used to spend hours manually finding clips, naming them, organizing them, and sending links to the people who played. Now, the system helps pull titles from the audio, identify song sections, name the clips, generate videos, upload them to YouTube, and organize the results into a searchable grid. What used to be hours after a session is much closer to a push-button workflow. That is natural language programming in practice. It is not only for enterprise software, it is for memory, music, food, medicine, family, scientific exploration, and whatever else a person can describe clearly enough. This is why I like the phrase bionic amplifier. The question should not be, will AI replace me? The better question is, which parts of my work should no longer consume my life? The bionic arm does not decide what matters. It extends capability. AI is similar. It extends reach, speed, recall, iteration, drafting, summarization, comparison, and routine execution. But judgment still belongs to people. This is especially important when we talk about software engineering. I do not think the most useful framing is that AI simply displaces software engineers. The better framing is that many more people can move up a level. Instead of spending all our time as implementers, we can spend more time as designers, directors, reviewers, editors, and people who understand the purpose of the system. The coding agents can manage more of the mechanics, but the human still has to define the thing worth building, recognize when the output is wrong, and decide what consequences matter. That is not a smaller human role. It is a more demanding one. And that brings us to content. Content is king. Content is currency. Content makes kings. Models are only as good as the human content beneath them. A model that memorizes can look brilliant on what it has already seen and break badly on what it has not. I learned that lesson early. The curve from my 1991 Berkeley thesis is a simple version of it. Overfit the training data, and you can fool yourself into thinking you understand the world. Then the held out point exposes you. The same thing happens now at internet scale. The scarce resource is not only compute, it is not only model size, it is fresh, honest human content. The questions we ask, the documents we preserve, the experiments we run, the photos we label, the stories we tell, the mistakes we admit, the judgment we apply. AI meets people where they are. Broken English, another language, a third-grade phrasing, or millions of lines of code. That is the democratic promise of this interface. But the system still depends on us. If we stop producing serious human content, the system collapses into imitation. So preserving content is not nostalgia, it is infrastructure. Looking forward, the next phase is movement. For the last few years, the AI story has been mostly about language, what machines can say. The next act is about what machines can do. Intelligence is starting to leave the data center and step into the room with us through sensors, joints, actuators, balance, grasping, walking, driving, lifting, and manipulating the physical world. The baseball image is there because hitting a 100-mile-per-hour pitch is one of the hardest human problems. You do not simply react. There is not enough time. A great hitter predicts, commits the body, and then fuses that forecast to a violent, exquisitely timed motion. Prediction plus execution as one act. That is embodied intelligence. The robot hand and light bulb image points to the same idea. Dexterity helped build the human brain. A remarkable share of our cortex serves the hand. Building a machine that can think, perceive, and move gracefully is much harder than building one that can generate text. There is risk here. Obviously, automation can displace work, but it can also remove back-breaking, health-eroding labor from human lives. Whether that becomes cruel or humane depends on the on-ramps, retraining, safety nets, and choices we build around it. Again, technology is not a fate. It is a tool plus a culture. That is why I use the fire analogy. The answer to fire was not to extinguish it. The answer was to learn how to carry it, contain it, teach it, and build hearths around it. Fire illuminated, warmed, cooked, protected, and transformed human life. It also burned people and destroyed cities. Serious tools require serious culture. AI is like that. Naive optimism is not enough. Fear is not enough either. We need responsibility plus access. Berkeley is extraordinary. Sung-Hou's lab was extraordinary. But the next brilliant person may not have Berkeley access. They may not have the mentor, the lab, the conference, the network, or the permission structure that I was fortunate to have. AI can help more people find serious lanes to swim in. Not by lowering standards, but by lowering the intimidation barrier. Not by pretending expertise does not matter, but by helping more people reach the point where they can engage with expertise. So I want to close where we began. At that Gordon conference, Sung-Hou modeled something I did not fully understand at the time. He showed how an expert can rescue a beginner instead of crushing him. That is the AI moment in miniature. Those of us who have been in the AI game for years have a choice. We can be the voice in the audience saying, "That's no big deal," or we can be the person who helps the next person keep going. For people who are just arriving, the message is also simple. Use it. Pick one task this week that wastes time and let AI help you move through it. Share it. Sit with one person who is curious or fearful. Let them drive, translate, do not lecture, and preserve it. Capture stories, expertise, images, emails, notes, methods, failures, and memories. Human content is the fuel. The fire is already lit. What we do with it is still up to us. So my invitation is not, we already did this. My invitation is, come join the party.